Okay, so today I'm going to go over our NAE Grand Challenge, which is managing the nitrogen cycle. And to start off, I'm going to go over some background information on why this is a challenge. So, humans have started to find new methods to accommodate for the deficiency of nitrogen nutrients. And these methods have started to double the amount of nitrogen in the atmosphere and has increased the greenhouse effect and the ozone and has affected the ozone layer by destroying it, and drinking water has been contaminated through increased acid rains. So our challenge is to increase denitrification by creating more nitrogen molecules to reduce the amount of fixed nitrogen in the atmosphere. And there's a couple ways we could do this. First, we want to help reduce runoff, which gets into the water and increases acid rain and water pollution. And we want to find new fertilizer that won't produce the toxic nitrogen or into the atmosphere, and which then affects the greenhouse effect. So the data we chose shows how energy, waste management, agriculture, and industry have affected nitrous emissions over the years, and we will use this data to prioritize which problem to tackle. So it shows from 1990, I want to say 1999 to 2009, and we want to see which one of these sources has the most effect on the nitrogen cycle and the increase of nitrogen in the atmosphere. So I'm going to start by going through our code. And so, of course, we started off with CLC clear. And our problem statement is to create a program that will determine the year with the maximum nitrous oxide emissions. And then from that year, we want to determine which source was the leading contributor to the nitrogen emissions. And we will also find the average amount of nitrous oxide emitted by each source over the years. And then at the very end, I should ask the user if they want to input a specific year to find its data, like how much nitrous emissions were from that year. Okay, and then our input variables are very simple. We only have two because we just have to download the Excel file with our data. And we're going to name it data, and then our sources are going to be later on used in a cell array that has the waste, agriculture, energy, and industry sources that contribute to nitrous oxide emissions. And then here are output variables, which basically these four right here are just going to be used when we're determining the average amount of nitrous oxide emissions by each source over the years. So we're going to have the average waste, average agriculture, average energy, and average industry. And then this output variable max here is going to give us the year with the highest nitrous emissions. And then this max NE for that year will give us a source with the maximum emission from that year. And the max year emission will give the total nitrous emissions of max year. So to start off, we're going to use load, and we're going to load the data. So we're going to use XLS read, and this is the name of our file, and it should be in the folder up here. And so for the first thing we're going to do is take the size of the data, and we're going to name it row and col. And then the first thing we're going to do with that is to sum the data. Well, we're going to sum each row. So first we set up a matrix of zeros, well, not a matrix, a vector, and then from there we made a nested for loop, and then we're going to start at 2 for column because the first column is years, and then we're going to sum each column, and then we're going to put it in a vector called sum data. Okay, and then so then from there we're going to use that vector to find the max. So we set the max year emission to negative infinity at first, so whenever it is greater than that, it can equal the max year emission. And then from there, once we find the max year, we're going to take that year and then we're going to equal to 1990 because that's just the column number. So we're going to start it off with 1990 plus I and then subtract 1 because of the year vector, the year column at the beginning. Okay, so then we're going to find which source had the highest nitrous oxide emission in the max year. So first we're going to create a nested for loop to go through that vector, and we're going to input the index, which is the max year minus, so that's just the column number basically. And we're going to find which one has the max NE year, which we also set to negative infinity. And once we find that, we're going to get the column number for that. And so we're going to do I2 is equal to C minus 1. Again, C minus 1 because of the year column. And then we're going to use that to find, okay, so here's the sources that I mentioned earlier. And so we're going to plug in that index to find which source in, because this is the labels in order of our data. And we're going to plug in that index to find which source was the highest contributing source for that year. So we're just going to do sources and then plug in that index. So let's say it was I2 is equal to 2, it'd be waste management. Okay, so now we're going to find the average nitrous oxide emissions for each source throughout the years. And so we're going to just take the mean of the data vector we made earlier. And okay, so data, and then we're going to do the column. We're going to do all rows in column 2 because that's the energy is the second column, waste is third column, average agriculture. So agriculture is the fourth column, and we're doing all rows for all of these, and we're just getting the average of each of their columns. And so we're going to make them into a vector right here. We're going to put average energy, average waste, average agriculture, and average industry. And then we're going to do the max, like we did earlier. We're going to set max average source emission to negative infinity, and then we're going to find from these which one was the max average. And then find the index again and do the sources and plug in the index to find the max average source. Okay, so now from here we're going to find the percent averages of the max source. So right here, let's say the max source was agriculture. We would plug that in and divide by the sum and multiply of all rows of the whole thing and multiply it by 100 to get the percentage. And we're going to call that percent max average. And then we're just going to start doing fprint statements here, and we're going to print the maximum nitrous emissions for whatever year it occurred in. So we're going to put in max year emission and max year, because max year emission, as we had stated above, is the total nitrous emission of that year. Okay, and then for our next fprint statement, we're going to say which one was the highest contributing source in that year. So let's say which is max NE for that year, which we just determined, was the source with the maximum emission for that year. And again, we're going to output max year again. And then the average nitrous emissions throughout the year. So that's where we're going to use these averages we used earlier. And we're going to make a table. So we fprinted by using tabs and new lines. So first we're going to do energy, waste management, agriculture, and industry, just like the Excel file. And then we're going to outprint. We use like 3 tabs each, and we're going to outprint the average energy, average waste, average agriculture, and average industry. And then, so that should be a table with this being the title and these being directly under it. And then we're going to say also what the highest contributing source of nitrous oxide throughout the years and what it made up out of the total average nitrous oxide emissions. So we're going to find the max average source throughout all the years and the percent that it made up, which we found right here by multiplying this by 100. Okay, and then finally we're going to start plotting. We just want to show the user the different sources and how much they made throughout the years and the differences between them. And so we're going to plot each data. So this is the first row, second, and first column, second column, first. So that's going to be the years versus the first one, which is energy, and then this is the years versus hold up. See the order again. It's going to be years versus energy, years versus waste management, years versus agriculture, and years versus industry. Okay, and so we're gonna just grid that, and then we're gonna make the lines, and then we're gonna label it time for the x-axis and nitrous oxide emissions for the y label, and it should um, plot each of these sources individually and show us the differences. And then our legend here is just the sources: energy, waste management, agriculture, industry, location, and the location and best, we're just including that to show you which one is the highest. And then for our last part of our code is to ask the user if they would like to view the nitrous emissions of each source for a certain year. So this is going to come out as a menu, and if they put yes, the value will equal to 1. So we made a while loop that said while yes or no is equal to 1. That will only start if they put yes. And so they're going to end up, we're going to say which year is equal to input, enter the year between 1990 and 2009 that you would like to check. So to start off, before we do anything with that year, we're going to check if it's in the range of 1990 and 2009. And then, so we're going to make another while loop inside, and then while it is out of the range, it's going to keep asking enter a year in the correct range. So if which year 2, we're going to do the same thing we did above, because this is just giving us, we're going to try to find the index instead of just the year. So we're going to subtract 1990 from it to find which column it was. And then we're going to fprint, like we did above, a new table that will show the nitrous emissions in million metric tons from each source in the year. And then we're going to put in that fprint statement which year they provided above. And then we're going to make a new table: energy, waste management, agriculture, and industry, and print all of the average values, which we're going to do here by saying data which year 2, which is the index, and then we're going to print the average of column 2, which is energy, average of column 3, which is energy, waste management, and then agriculture and industry. So then at the very last line of code, we're going to ask if they would like to enter to view the nitrous emissions for another source, which is again a menu of yes or no. And if they put yes, it should run again because of the while loop above. So I'm just going to go through this data and show you how it works. So right now, it should work fine. So it's going to start off. Okay, let me minimize that for now. Okay, so it's going to start off by giving us the maximum nitrous emission was 241 million metric tons, and it occurred in the year 1994. So from the data we have from the Excel file, that it found that 1994 had the highest nitrous emissions throughout the years from 1990 to 2009, and that agriculture was the highest contributing source in that year. So, and then we also found the average nitrous emissions from each source throughout the years, and it was showed that energy was 48, waste management was 5, agriculture was 151, and industry was 20. So it was apparent that agriculture had the highest average. Sorry, my tabbing is wrong on this computer because it is a Mac, and I have my code from a Windows computer. So, but it would have been aligned with these titles. And then we're going to say, so from this we see that agriculture was the highest contributing source of nitrous oxide throughout the years, and it made up 67% of the total average nitrous oxide emissions, which is really evident here by seeing how much higher agriculture is compared to industry, waste management, and energy. So this makes sense, and 67% seems very accurate. So what I minimized earlier was the plot. And so here we see the legend we described earlier, and we see that agriculture is by far the highest contributing factor compared to energy, industry, and waste management. And we see by 100 metric tons the difference, million metric tons the difference. And these are over the years 1990 to 2010. So throughout the years it hasn't changed much, but you can see that agriculture has always been the leading factor. And I also minimized earlier the menu, and it's asking, would you like to view the nitrous emissions of each source for a certain year? And I will say yes. and I'm going to put a source, I put a year that is outside of the limit. So let's say I put 1989. It should ask again. Let's say I put 2010, which is also off the limit, so it won't give it to me. So then I do 2009, and it'll give it to me for that year, 42, 5, 161, and 11. And I said, would you like to view the nitrous emissions for another year? I'm going to click yes. And I'm going to put, again, another source, a year out of the limit. So let's say 2010. And then I'm going to put 2008, which should be in the limit. And then I found it for that year as well. And again, the tabbing is wrong because this is a Mac and we did it on a Windows computer. So I'm going to finally say no, and the program should end. So thank you so much for watching, and I hope this helped you understand our data and what we used our code to find. And I also hope this data can be used in the future by, let's say we do find ways to help reduce nitrogen emission from agriculture. Maybe they could use this data by inputting the new data for different years and see that agriculture has decreased its nitrous emissions, and maybe show improvement throughout the years. And I hope this helps tackle the problem in the future. And thank you for watching.